Hi all, welcome back. So in this session today we are going to talk about a vibration sensor or a tap module. Okay, so how does it work? Let me before I talk about that, okay, let me quickly show you how it looks like. Okay, so I have in my hand, okay, and this is how it looks like. So this is the sensor which I have, which is a tap module, okay, or a vibration sensor. It can be used with your door, and then if you somebody knocks and all, right, so you would like to take certain kind of actions based on that. Okay, so before we go on how to use it for our practical purpose, the one thing is we have a 3 pins over here. Okay, and this 3 pins are, one is ground, one is the voltage power or the VCC, and the one where I'm going to take the output from, right? So based on whatever knock I will do, I'll get the output. Okay, so normally this is the diagram. So it is a switch. It is normally a open switch, okay, that is held high. Okay, so by default it would be held high and it will send a high signal or 1, okay, because of the pull-up resistor which we have used with the power, okay, and between the power and from where we are going to take the output. The moment you knock on this, okay, the moment you knock on this, right, the signal will become low and you can take certain actions based on that. Okay, and you can use it in a different way. Okay, so right now we have two objectives to be achieved. One is we would like to take actions immediately. So the moment somebody knocks on it, okay, we would like to do something about it, that some incident has happened. Okay, the second thing what we are trying to achieve is we will see that there is no further activity has happened on this sensor before we say that there are that it is dormant or no knocks has happened. Okay, so we will sufficiently wait for 750 milliseconds before we say that there are no knocks. Okay, so once you do a knock, right, after only 750 milliseconds, okay, it will go into a no knock situation, no knock alert. Okay, so let me quickly connect my, so it's easier. Okay, so I'll connect one pin to the ground, okay, one pin to the power supply and one pin to the output. I'll quickly connect to my Arduino. Okay, so let me just connect it fast for you. The center pin is the power pin or a 5-volt pin, and that I'm gonna connect now. Okay, and I'm gonna connect the ground pin too. Right. So now I have done everything, and let me just quickly show you the code base. Okay, so what I have in the code is pretty simple. Okay, so there is like 10 lines or 15 lines of a code. What we are going to do, we are collecting the output from the pin number 10. Okay, so if you see this diagram, okay, so the output I'm going to connect to my Arduino pin number 10. So this is my output which I'm going to connect to my Arduino pin number 10, and that is what I have defined in my first statement. And normally if you see it is high. Okay, as I mentioned, it will be in a high, okay, or a high state. The moment I knock, okay, so I'll try to continuously read from pin number 10. The moment somebody knocks, what will happen to this knock value? It will become low, right? So that is what it will happen. I'll try to read from this knock pin, and if it becomes low, then there was a knock, right? And then we will see knock time. Okay, we'll basically get in terms of milliseconds. Okay, and the alarm, we will also see we have also defined a flag, okay, that is called alarm flag. If the alarm flag is true, okay, in this case, then what will happen, it will print a knock knock and then maintain this alarm state of true. Okay, and then it will go into a else loop, and it will just calculate based on two conditions. One is alarm is true. Okay, so normally if it comes from this loop, the alarm would be true. Then it will say it will just calculate that it is more than 750 milliseconds. So knock alarm time is we have defined here. Okay, so 500 milliseconds we have defined here. So it will calculate based on that. Okay, and it will see if there is, that is more than 500 and this is also true, it will say there are no knocks happen. Okay, right, it will take the current milliseconds, it will take the last knock time, try to do a subtraction, and if it is more than 500, okay, and this is true, then it will say that knock has happened before some time, before 500 milliseconds, okay, and then I'll say my alarm is false. Okay, so this is my code. And okay, so one more thing which I'm going to do is, I'm going to do in the setup is, I'm setting a knock pin as an input. So basically we are getting the input from the pin number 10. That is what we have defined. And for the initial thing, we have defined alarm as a false, right? So we have defined everything, right? So what will happen now, I'm going to show you my output. Okay, so let me just close everything up, and I can see my output from my serial monitor. So let me see that. Okay, now what I'm going to do is, the first step I'm going to do, I'm touching my knock, I'm touching my sensor. Okay, and I'm trying to do a tab, right? The moment I do a tab, okay, so let me do it little harder. Okay, okay, so let me, can you guys see? Okay, so you guys can see, right? I'm going to do a tab. Something wrong. See, now I'm going to do a tab. Okay, so the moment I do a knock, knock, okay, so basically what I'm doing is, I'm saying knock, and then it waits for a certain time, and then it says it's a knock, no knock, right? I can increase the duration also. Before I give the alert of no knocks, I have to change a slight modification in the code, right? I can define my knock alarm time more than if it more than 5 seconds also. I can make this as a 500 milliseconds, 5000 milliseconds also, right? And this is very useful for a vibration, right? So it is also called as a vibration sensor also, right? As we have defined here, it is also called as a vibration sensor, right? So this is all for this module. We will meet for the next set of sensor in the next class. Thanks for joining the session. Bye bye.